Okay, let's get right into it. AI. If you're a Java developer like me, you've heard all the hype. But let's be real. For most of us building big enterprise systems, our reaction is, well, it's pretty standard.
And that standard reaction, it's usually a big dose of, yeah, right. I mean, we're the ones in the trenches, keeping critical systems online. We've got deadlines, we've got SLAs, we've got security breathing down our necks. We just don't have time to chase every shiny new thing, especially one that feels like it's from another planet.
I mean, this is it, right? This is what we all think. AI is for the data science folks with their Python notebooks. It's for the R&D teams building cool little demos. We build the production-grade, scalable, secure backends. It's a different job, a totally different world. We're Java developers. Yeah, but see, that's the thing. That idea is a total myth. And honestly, holding on to that mindset is probably the biggest career risk a Java developer can take right now. We have to shatter that myth today. The entire game has changed, and the reason is the Spring AI project. And look, this isn't some side project from a university. This is the Spring team doing what they always do, taking something incredibly complex and giving us, the enterprise Java developers, a familiar, powerful way to get the job done. Just look at this code. This isn't Python. It's not some weird academic library. If you've ever used Spring's web client or REST client, you already know how to do this. The Chat Client API makes calling a model like GPT-4 feel exactly like hitting any other REST endpoint. We're talking 4 lines of code. That's it. Boom, you're an AI developer. And here's where the classic Spring magic really shines. You write your code against that Chat Client API one time. Then, just by changing your configuration, you can point that same code to OpenAI or Anthropic's Claude 3 or Microsoft Azure or Google Gemini. You can even point it to a local model running on your machine with Llama. No code changes. That gives you total portability and means you never get locked into one vendor. It's brilliant. Okay, I'll give you that. A simple API call. That's clean, it's nice, but that's just a hello world. A real enterprise app isn't just sending a question and getting a simple string back. What about the hard stuff? What about making the AI actually know something about our business, our data? That's where the real patterns come in, and the biggest one you need to know is RAG. Now, this isn't about training a whole model from scratch. It's about taking your stuff, your technical docs, your product catalogs, your internal knowledge base, and feeding the most relevant bits to the AI along with the user's question. This is how you build a chatbot that can actually answer specific questions about your company using your information without just making stuff up. It is a key to making AI genuinely useful. And then you have function calling. This is the magic bridge that connects the AI's brain to your existing systems. It lets the AI model basically say, hey, I need to know the current price of this product. I see you've got a Java method called getCurrentPrice. Can you run that for me and tell me what you get back? This turns the AI from a simple chatbot into an intelligent agent that can actually use all the battle-tested APIs and services you've already built. Right. This is where the rubber meets the road. All that stuff is cool in a demo, but these are the things that senior engineers and architects have to deal with. What is this going to cost when we run it at scale? How slow is it going to be? And what is our security team going to say about sending customer data to some third-party API, especially with laws like GDPR? And you're absolutely right to ask about cost. Let's make it real. A customer support bot, handling maybe 10,000 conversations a day on a powerful model like GPT-4, that could easily run you $7,500 a month. That's a real number that will get a lot of attention. But thinking of it as just a fixed cost is the wrong way to look at it. So how do we fix that? We get clever. We use a strategy called model cascading. It's simple. You don't send every single request to the most expensive, top-of-the-line model. You start with a cheaper, faster model first. Then, you let that model tell you how confident it is in its answer. If it's not very confident, only then do you pass the query up to the big, expensive model. Just doing this one thing can slash your costs by more than half, without your users ever noticing a drop in quality. And compliance? That's not a new frontier. It's a solved problem. Look at the difference here. If you go directly to OpenAI, you're dealing with tricky data residency issues. But if you use an enterprise-grade service like Azure OpenAI, you get the whole package right out of the box. Full GDPR compliance, guaranteed data residency in the EU, private network access. Your security team already knows and trusts this stack. It's literally built for this. And all the other production issues have solutions too. Worried about latency taking seconds? Semantic caching can get your response times down to milliseconds. Need to store your data for RAG? Spring AI already integrates with over 15 vector databases like pgvector and Redis. Worried about getting locked into one cloud provider? A hybrid strategy is easy to set up. See, these aren't some kind of AI magic problems. They're just engineering problems. And solving engineering problems is what we do. So, when you pull all of this together, what does it actually mean for us? It means there is a massive, massive opportunity right in front of us. This right here, this is the single most important takeaway. The most sought-after engineer in the very near future isn't going to be the Python data scientist. It's going to be the person who deeply understands how to build secure, scalable enterprise systems, and who also knows how to plug these incredibly powerful AI tools into them. Just think about it for a second. As a senior Java developer, you already own the hardest parts of the equation: security, data, scalability, reliability. With a tool like Spring AI, the AI part just becomes another library to integrate, another API to call. You are in the perfect position to build these next-generation AI features on top of the robust systems you already manage. That combined skill set barely exists today, creating a huge supply and demand problem in your favor. And the best part is, the gap between where you are right now and where you need to be is way smaller than you think. So I want to leave you with a simple challenge. Seriously, don't overthink it. Go to start.spring.io, add the Spring AI and Llama starters so you can run a model locally on your own machine. Then just create a single REST controller that takes in a question and returns whatever the AI says back. That's it. That's your first step. It might take you an hour, maybe two, but taking that one small step will completely demystify this whole space for you and set you on an entirely new career path. So the technology is here. The business cases are crystal clear. The only real question left is, who's going to build all this stuff? Is it going to be the developer who keeps thinking AI is somebody else's job? Or is it going to be the one who realizes it's just the next powerful tool in their Java toolbox? The choice, really, is yours.